which line segments produces a triangle. For example, given points A, B, and C connected by the line segments line AB, BC, and AC, we have a triangle as shown below. Triangles are classified by their angles and their sides. All angles in an acute triangle measure less than 90 degrees. One of the angles in a right triangle measures 90, and again we have that little square symbol in it. And one angle in an obtuse triangle measures between 90 and 180. Sides that have equal length are indicated by hash marks. And we have a figure here that shows the shapes of the basic triangles, their names, and their properties. A few other facts to remember. Points where the line segments meet are called the vertices, or vertex, which is plural for vertices, which is plural for vertex. And we often refer to sides of a triangle by the angle they are opposite. In other words, side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. So going here we have B, angle A, angle C, C. So first up we have what's called an acute triangle. All angles are acute, less than 90 degrees. Then we have what's called a right triangle. One angle is a 90-degree angle. And the side opposite of that is called the hypotenuse. Okay, an obtuse triangle, one angle is obtuse. And we have an isosceles triangle. At least two angles have equal measure, and the sides opposite the equal angles are congruent. That means they're the same length. An equilateral triangle, all sides are equal, and all angles are equal. A scalene triangle, all sides have different lengths, all angles have different measures. So let's talk a little bit more. Special note about right triangles, the side opposite, I've already said that, is the longest side is called the hypotenuse. One of the most important properties of triangles is that the sum of the interior angles equals 180 degrees. You could have discovered and proved this property using parallel lines. The completed sketch is shown below. So let's play with this a little bit and see if we can do that. So we're told that this line here and this line here are parallel. So I have angle C here. It's the same as 5. Same measure. Vertical angle. Then I have two parallel lines intersected by a transversal. Alternate interior angles are equal. So 4 is equal to 3, which means this is equal to 3. All right, so this would be the same measure as angle 5. This would be the same measure as angle 3. And again, I have parallel lines, transversal. 1 is equal to 4. No, 1 is equal to this. Then when I look at it, it's 180. So let's find the measures of each angle in the triangle shown. We have x plus 1 degrees plus x minus 19 degrees plus x degrees, and it's going to equal 180. So I have 1, 2, 3 times x at 1 minus 19 minus 18 equals 180. I get 3x equals 198. X equals 66. degrees. So this is 66 degrees. This would be 67 degrees. And this would be 66 minus 19, which is 57 degrees. And if we add them all up, 124, oh, wait a minute. I think we did that math wrong. Yes, 47, not 57. And then when we add them all up, 47 plus 67 plus 66, we should get 180. Okay, let's get a little different here. Find the measures of angle 1, 2, and 3. Well, let's see what we got going on. Well, here I have two lines intersecting vertical lines. Measure of angle 3 is going to be 60 degrees, right? Here I have the same thing. So what's this measure? Well, it's simply 180 minus 145, which is 35. Now, if this is 35, the measure of angle 1 is 35 as well. And then to get the measure of angle 2, 180 minus 60 plus 35. 180 minus 95 equals 85. Okay, so now we're going to talk about congruence. If two triangles have equal angles and their side lengths are equal, the triangles are congruent. In other words, if you can pick up one triangle and place it on top of the other, they coincide, even if you have to rotate it. So in the figure shown is triangle ABC congruent to triangle DEF. Well, let's see, what do we know? We know that this angle here, angle F, is the same as C. And we know that angle D is the same as A because of this, which tells us also that angle E is the same as angle B. Now the side across from E, so we would call this side E, is the same as the side across from B. They're equal angles and the side across are equal by the hash marks. Then the side opposite angle D, which is equal to angle A, and two hash marks, so these are equal. So that would mean that yes, they are. So now we have congruence theorems. There's three of them, I believe. Following theorems are tools you can use to prove that two triangles are congruent. We use this symbol, which is basically an equal sign with a squiggly line over it, to define congruence. For example, a triangle ABC is congruent to triangle DEF. The first way is called the side-side-side, or SSS. If three sides of one triangle are equal to the corresponding sides of the second triangle, then the triangles are congruent. Next is the side angle side. If two sides of a triangle and the angle between them, that's important to remember, are equal to the corresponding two sides of the included angle of the second triangle, and the triangles are congruent. And we have angle side angle. If two angles and the side between them in one triangle are congruent to the two corresponding angles and the side between them, the second triangle, as we see here. Oh, and then there's the angle side. If two angles and a non-included side of a triangle are congruent to two angles and the non-included corresponding side of a second triangle, then the triangles are congruent. So what are we looking at here? We're looking at two angles, this one here and this one here. And the only side that's not used in them is this one. This one and this one. Side opposite. Okay? Equal. Angle, angle, side. Angle, angle, side. So identify the congruence theorem. Well, I have side, angle, side. Side, angle, side. What about here? I have angle, side, angle. Similarity. Two triangles have the same angle measures and are the same shape but differ in size. The two triangles are similar. The lengths of the sides of one triangle will be proportional to the corresponding sides of the second triangle. Note that a single fraction A over B is called a ratio, but two fractions equal is called a proportion, such as A over B equals C over D. The rule of similarity applies to all shapes as well as triangles. Another way to view similarity is by applying a scaling factor, which is the ratio of corresponding measurements between an object or representation of the object to an image that produces the second similar image. So, is triangle EFG similar to triangle JKL? So we have this to help us in this. So we have two angles that are the same, which means all three angles are the same. So should be some common proportion. So is there? 3.7 to 4.9, the same as 6. Oops. 5 is the 6.6. Does this work? And you know how to check these, right? Simply cross multiply. So to check to see if, so right now we're looking to see if if they're proportional. So there's 4.9 times 5 and 3.7 times 6.6. They're not the same. So these are not. Because I get 4.9 times 5 equals 24.5, and 3.7 times 6.6 equals 24.42. So they're not proportional. So no. So let's look at this one here. This one's a little easier to calculate. Are these triangles similar? Find the lengths of the sides, X and Y, to prove your answer. Well, let's see. They didn't tell us the trick. So there is a theorem about right triangles. The lengths of the legs, A and B, squared is equal to the length of the hypotenuse squared. So we can use this. So let's look at this one here first. And we'll call this A. So we got y squared plus 18 squared equals 30 squared. Three 24, y squared, 900. Subtract the 324 and we get 576. square root of 576 equals 24. Okay, so all angles are the same. We've determined that hypotenuse is 10 meters to 30 meters. So that's 10 times 3 is 30. 8 times 3 is 24. So that tells us, yes, they are similar. And then x times 3 is 6, or 18. So x is 6 meters, and y is 24 meters. I wonder if we were, and yes, they are similar. Okay, a person who is 6 feet tall is standing 100 feet away from the base of a tree. The tree casts a shadow 107.5 feet long. How tall is the tree? So we can go the height of the person is the 7.5. A 6 foot tall person has a 7.5 shadow. An unknown tall tree has a 107.5 foot shadow. Then we cross multiply. 7.5 equals 6 times 107.5. And we get 7.5x, sorry. 7.5x equals 645. Divide, and we get 86 feet. All right, what do we have here? A tree casts a shadow of 180 feet early in the morning. A 10-foot high garage casts a shadow of 30 feet at the same time. What is the height of the tree? Now we're looking at a tree here, and our shadow is 180 feet. We don't know this. Then we're looking at our garage. Our shadow is 30 feet, and it's 10 feet high. So these are similar triangles. They're both right triangles. They both have the same measure from the sun down. So 30 is to 180 as 10 is to x. We get 30x equals 1,800. X equals 60 feet. And that finishes up this section.